Okay, next I'm going to talk about hybrid simulation related technologies. So some of the functions we developed, we have, so that can be used for hybrid simulation. So I will cover the how to use calculation channel function, and so this is a in our controller software there's this function, and we use that function, and we have done a lot for regular tests, complicated tests using this function, and I will explain how to use this function in hybrid simulation. And also some virtual testing, and earlier I explained briefly, how to virtual test the hybrid test, to evaluate the hybrid test before actually conduct the physical hybrid test, and different methods, and also I will explain a little, if you use software other than OpenC's. For example, you want your own software, like Ansys, like Adams, like other things, and what I'm going to do, and how to connect your preferred software package with OpenFresco conduct hybrid simulation. So through this generic element, I'm going to cover that, and using Ansys as an example to show how to connect your software, preferred software, with the OpenFresco and do hybrid simulation. So, and first talk about calculation channel. So usually for a closed loop control, an actuator, a controller, and you have a load control mode and a displacement control mode. That's common. So you can flip here and use a load control and specify a load, and you can flip to here, and then you give a displacement control mode, and command displacement, feedback displacement. So that's very common, and everybody knows that. And using calculation channel, and then you can set up, you controlling something different. For example, here, I have this object. I have two actuators here. One's left and one's right. And so each actuator can control displacement or force separately. But sometimes I don't want that. I want to control the overall displacement and the rotation. So that it's you want to achieve the overall displacement and the rotation. It's a mix of the left and the right, and so you need to do some calculation. So to calculate the overall displacement, so the displacement is equal to the left displacement plus right displacement divided by 2. Rotation, you can approximate, the left minus right, and divide by the distance, and then calculate the angle. So to calculate the actual overall displacement, so you need to set up the matrix. So the XO is equal to M matrix left plus right divided by 2, and the moment or angle is left minus right, and divided by a constant or whatever. If we ignore the constant, and then is left minus right. Yeah. So that matrix defines the relationship between the actuator control and then the UF control. And so same thing, you inverse this matrix, you got the left, right, and you go to the XO, the moment or angle. Yeah. So you just inverse this matrix, put it here. So that calculation can all be done using the calculation channel. So this is a simple degree of freedom control. And so through calculation channel, you can realize this kind of thing. If you want to consider nonlinear and large deformation, so the relationship is not linear anymore, so you need to use our sophisticated degree of freedom control software. Yeah, that's another topic. So let's continue. So now I want to control overall translation and the rotation angle. Then I have two actuators. So then the command got to be translational, rotation angle, and then through the calculation here, and then inside it can convert that command to actuator space, and then convert actuator space and give the command to the actuator, and the feedback, same thing. Feedback from actuator space convert to the DUF space and give the feedback, and so makes a closed loop. So there are two kinds of calculations. One is here from the global coordinate to the actuator coordinate, and then also there's another calculation from actuator coordinate to the global coordinate. So those calculations corresponding to the matrix here and the matrix here. So to do that, and using calculation channel, and then this is our station builder software. You can set up this kind of calculation. So first you set up, one is translational, one is rotational degree of freedom, and so those degree of freedom is the feedback is calculated, not from a specific transducer, and then. So you need to enter the equation to calculate the translation. So left plus right divided by 2. That's right here. That's this relationship. Left plus right divided by 2. And then, so you enter this equation here through calculation channel function, and the same thing. Translation force. Rotational displacement, rotational force, you can enter all the equations here. And so this is from global coordinate to local coordinate. And the same thing. So the other translation is from the local to global, and the calculation you can enter according to the relationship, according to this equation, from global to the local. Yeah. So you enter the from local to global and global to local, and then you set up your calculation channel. So now you have your calculated channel to control 2 degree of freedom. And one is translational, one is rotational. And then, so this station can be coupled with the open fresco and to control the 2 degree of freedom in global coordinate system rather than in the actuator space. So, but this is this calculation is a linear calculation. Doesn't consider the large deformation. If there's a large deformation, you need to use our degree of freedom control software. So this is just an example how calculation channel can help you. And the calculation channel function can be a lot more complicated than this. And actually, pretty much all the calculation can be implemented by C language. Then you can implement that through the calculation channel. So a lot of complicated transfer function and filtering and friction compensation, delay compensation, all those things can be done using calculation channel. So so the calculation code, and when you open the station, the calculations automatically downloaded to the controller and run it in real time, and keep the clock rate, and it's just like a real-time controller right there. So here's an example, another example. This is a calculation channel example, and Celine talked about the explicit numeric method, and that method, integration method, can be implemented in calculation channel. And so this is the code. And then you can also build a FEA model using the calculation channel as well. So actually, this is a real-time hybrid simulation test done by NCRE people using calculation channel. So they build a FEA model, this structure, FEA model, and compensation, and integration method, it's all within calculation channel. And calculation code becomes more complicated, and so this is just a part of the code handling the integration, and so the model building part and other parts are not showing up here. So that they only use this calculation channel. They're only use the controller, no target PC, no displays, and those things, and then they did a real-time hybrid simulation. And they compared this hybrid test and with the trigger table test, and we got a good correlation. So you can see that you can only use you can use calculation channel only, and then you can do a lot of things, including a real-time hybrid simulation. So the delay compensation part, and you have the different methods, and you have a transfer function to simulate the command and feedback, and characterize the delay characteristic. You characterize the roll-off characteristic, and then you inverse that transfer function, and then use that as a delay compensator. And that delay compensator can be realized using calculation channel. And so here's the code for one of the hybrid tests we did. And so the transfer function, inverse transfer function between the command and feedback is implemented through calculation channel. And then so so if you use this channel, and then the command automatically go through a compensator, and then the delay before this delay compensator, the command and feedback, you can see there's a delay, and after that the delay is gone. So all realized by this calculation channel. And a lot of times the feedback is noisy because of the electrical interference and stuff like that, and the noise causes a lot of iteration problem, convergence problem. So if you want to filter the noise out, and the filter can be easily done in calculation channel, and we have an example code for different filters. You just pick one and copy and paste, and then change some parameters like the passband. Then you have your filter, and then the signals, and before the filtering pretty noisy, and with the filtering it becomes much smoother. And later on, and Martin of Polytechnic in Montreal will probably show you another example how we use this calculation channel. Can you can compensate, you can eliminate the noise, And so we used some kind of a polynomial approach that was realized by using calculation channel. So in conclusion, so calculation channel function, is very powerful, and a lot of our customers do not realize that, and so we hope that this function can be used more and more in hybrid simulation, in regular tests, and help you guys. Yeah. So, so next, I'm going to talk about virtual testing a little bit more. I mentioned that, and hybrid test sometimes is very dangerous, and you have your powerful actuators, and could cause a lot of damage, and also in the hybrid test, the command is generated by your FEA model. It's not predefined. So in the regular test, process static test, you specify the amplitude, the frequency, but the hybrid test, there's no place for you to specify the command. So that if the model runs unstable and you don't know what the command is sent to the controller, so could be very easily damaged to the specification. So to do a good hybrid test, so you need to simulate the test first. Make sure it's stable, make sure it's safe, then you turn on the hydraulic. So then the virtual testing to simulate the hybrid test, so that's very important. And also for us it's more important because we have customers all over the world. So before we go to customer site, we need to make sure the test will be successful before we go there. Otherwise, the travel, stuff like that, could waste a lot of money. So, we have different kinds of virtual testing method, and the first method is FE, adapter element method, and developed by UC Berkeley and open fresco based, and you can choose so this method can couple 2 or more displacement based FEA program. So this is one of the core simulation methods. So so you use one FEA package and simulate one substructure, maybe numerical substructure, and then you use another FEA package, simulate maybe physical substructure, and then so these 2 FEA packages run concurrent simultaneously and simulate the real test. So this is a test rehearsal method, and it could be used for slow hybrid test and real-time hybrid test. So for real-time hybrid test is especially important because there's a stability issue, stuff like that could cause damage very easily. So so this is an open fresco based called simulation method, and so make sure everything hybrid test is set up properly, correctly, and stably, and then so after that you have confidence on your setup, and then you can turn on the hydraulic. So in this approach, so you need to select one program as a master to solve the maybe numerical substructure. For example, you can choose open frescoes to do this, OpenSys to do this. And then the remaining substructure, you consider as a slave model, and you use a different software, different package or same package to model that. and then you use OpenFresco to do the connection, and so advantage is OpenFresco based, and so you can the connection is OpenFresco based. In the master, you have a super element and sends out the command, and in slave you have an adapt element to accept the command. So, and because it's OpenFresco based, you have OpenSeas and OpenFresco connection, and then you can have a different FE package to be used as a master or slave. So that the feedback can be from during the test. The feedback can be from this slave, or can be from the real test system, and then you have a knob here. You can switch, first 100% from the slave, and then is that stable? Then 10% from the test, and 90% from slave, and then you can adjust this knob, and finally 100% from the test. So, and then the calculation channel I explained can be used to do this virtual testing all the system. You can model using this calculation and do the virtual testing. So because of the time, we cannot go into the great detail. Sometimes you can have your controller in the loop to do hybrid virtual testing. So the controller part is the real system through SquareNet, and then send a command to the target PC. Target PC has your virtual system. So virtual system is simulated by Simulink. Okay. So then, we have Adams and Simulink hybrid test. The mechanical part is modeled by Adams, and then the rest part is tested. So because of the time constraint, I cannot go very detailed. And lastly, I will talk about how to create a user-defined element to connect different FE packages to OpenFresco. So this is the work we did at Denmark Technical University, and they use ANSYS to do a numerical analysis. So we need to connect ANSYS with OpenFresco. So we developed this generic element and with address, and this is a part of the code. And then after we develop this generic element, and then we use this generic element here, connect to OpenFresco and do the hybrid simulation. And so this is some test and the data, and because the time frame we cannot go very detailed. So in conclusion, we talked about the virtual testing, different methods, and cost simulation, and so those are very useful functions. And also we talked about how to generate a generic element to connect different packages to OpenFresco to do the hybrid simulation. Sorry, because the time is so short, I couldn't go into very detail.